I hope so. I hope the weather will be nice.
Yeah, I'm alive. Nice. Um, did any of you folks had a chance to look at the final like merged vision? Uh,
Not yet. Do
no?
you have the link again?
Yeah, let's send it
Oh,
here. Oh, it's basically just in the last part.
okay.
So I basically just tried to whatever we had written down. I just tried to merge everything together without having duplicates, like duplicate features, duplicate requirements. Um, so I think I can go through it and then we can discuss whether something is missing, something is needed to be added, and then we can do it there. But otherwise, you have time to take a look at it after the meeting as well. How does that sound? Or do we want to do something else?
No, I think we can go through it.
All right. Uh, let me share my screen in a sec. And then we, of course, also have to figure out what to do after that. So let's see. All right. So for JSON schema documents, it's basically like a single source of truth, as we discussed last time. Um, I think I added, so like everything has to be well tested in terms of like we don't break these schemas because they're like the core of every validation that we do. Same with auto completion, etc. Can validate partial documents, so you can, for example, only validate a message object. Should be possible to do. Can be used across all programming languages. Can validate all official bindings and compatible versions, meaning that like even if you have multiple versions of a binding, all of those should be valid and validated if possible. Um, integrated with various IDEs in the terms of auto completion validation. So we make sure, for example, that descriptions, examples, default values, all of these like small things are also added, like metadata. So it makes a better IDE like experience, developer experience. Because right now I only think we have it for version 3, if I'm not mistaken, or 2.6. Distributed documentation and reusable components references. Should follow validity rules. Like, for example, you must have at least one channel, server must be URI. So those like format specific validation rules should also be in effect where possible, of course. I'm pretty sure this is actually wrong now that I think about it. I don't think we have a requirement. Are we missing anything or something that needs to change? No?
No, I think it's pretty complete.
Sorry?
I think it's complete. I don't have anything else.
What do you think, Zurich? Same? Okay. Parser. Um, regardless of what language that you build the tool in, you should be able to parse an async API document, validate it, and interact with it, like get information from it, and iterate over it. So that means that it can handle all possible references, both including private registries, local files, non-JSON YAML references, etc. And it, of course, should also be able to handle something like circular references. You should have a interface that gives you like a one-to-one representation of the async API document, depending on what version of the async API specification you use. So it means that you get like those type models that are changing based on what version you're using. You should be able to load async API documents from file, URL, supported data structures, basically the same as references in some sense. Like you should be able to access those async API documents and parse them from anywhere. Production level interaction that separates the async API version and how you get information. So this one was the one that was a bit confusing last time. In a sense, from my perspective, this one is closely related to being. So for example, when a new async API version comes out, you shouldn't need to change much in your implementation in order to support the new version. There should be like an abstraction layer in front. That's what this one basically means, as I read it. The parser can validate the async API document, bindings, extensions, and different schema formats. And it can, of course, also handle like schema format, custom schema format, both from parsing them and validating them. For example, if you have a custom proprietary schema format you use, you do you. Every parser must also have a great documentation so the user basically knows how to use it. Ensure we have proper testing kits across parser implementations, meaning that basically all our parsers regarding of language are well tested. Each parser should have a language specific convention. Like it should follow, for example, if the convention is to use lowercase for properties, then you should use lowercase. And if it's something else, use something else. Just so we don't force it across languages, but try to be as native in each language as possible. But it should still have the same look and feel. Basically, the developer experience should be the same. You should be able to serialize and deserialize async API documents. So once you parse it, you should also be able to serialize it again. So it gets like from, what's it called? From in memory to JSON and from JSON to in memory. Like you should be able to load it and deload it as you wish. That's what I understand by serializing and deserializing it. And lastly, like show meaningful and helpful error messages if invalid. So like you shouldn't have to guess what the problem with an async API document is if something is wrong. Right now, it's a bit of a problem. Lorenz, I think it was you that included this, or it might have been Suvik, I can't remember. Include JSON schema generation if possible. I couldn't put what this was and how to integrate it into the feature list.
Yes, it was me, and we can remove it.
Okay.
Yeah, I think it just belongs to the code first tools, so we can remove it from there.
All right, so it goes down to the code first tools.
If we don't already have it. Um,
You mean this one, well, basically?
No, yeah, you can actually edit because this is something else. I would say I
Okay.
can say something better.
Okay. Anything for this one up here for the parser? Anything we want to add or like glaring?
I have just one question.
Yeah.
Basically, one point says provide interface for one-to-one representation, and then you also said something about this one, yeah. Like, is this not like contradicting each other a little bit?
It is, and it does mean that you probably need to provide two interfaces, but one does not exclude the other. You can almost see like the production level interface is like a layer on top of the one-to-one representation, where it hides some of that logic that you need to do. For example, let's say that you want to iterate over operations from version 2 to version 3. That means in version 3, you have the operations root keyword, and then you iterate over that. From the version 2, you have to go through channels, then you go through operations. But the intent behind it is basically you as a user just want the operations. And then you want the channel, of course, and all that information, but you don't really care where in the async API document that information lies.
Okay. Yeah, I think it makes sense, but is this not more of a implementation detail of the libraries?
It kind of is, and it kind of isn't, because if it's an interface that is across all parsers, then it's the same as us writing this one here, in my mind. Like how we do it, I don't care. Like I don't care how we provide that production level right now. It's more the idea behind I don't have to change anything but to upgrade a single version of my dependency. And then I support version 4 of Async API.
You mean
Without have sorry, go.
you mean upgrade from a user's perspective? Someone who uses the puzzle?
Yeah, so if I'm building a tool and I'm using this new parser that we're building,
Mm-hmm.
I install version 1 of that parser. Once a new async API version comes out and we have this production level interaction interface, it means that I just have to bump my, in theory, like just bump my parser version a feature version, like a minor version,
Yeah, okay.
and then it works.
So it's not breaking every time we change the async API.
Yeah,
Okay,
but if
yeah.
you use this interface, then you are explicitly breaking it, right? Because you have the one-to-one representation.
Okay. Understood.
Anything else? No? All right, moving on. Code first tools. So yeah, engineers should always easily be able to use code to document their applications, basically annotate their code, instead of having to use design first approach. Which means that you should be able to annotate something in code that the async API specification allows, right? Like any information. If it has a description field, if it has a summary, all of those things need to be available to you so you can, what's that called? Like, should be able to provide it. The tool should also output an async API document, meaning that you can take whatever you have in code, get an async API document out of it, and prop it into some other tool. whatever that other tool may be, documentation or documentation generation or whatever, basically. Can output the reverse perspective, which means that once you describe your app, it also means that you can like flip the operation keywords and provide the reverse perspective, meaning that someone is interacting as an application with that one. Make sense? Can document an application through code in any language, meaning that, well, you should be able to do it in C# as much as Java, Kotlin, or Go or Python, right? Can be integrated into existing frameworks, meaning that it's probably not only a standalone tool, but it might also be integrated into something larger. Not sure exactly what that means in an implementation-wise perspective, but yeah. Then there was something about can easily be integrated into a broker interaction, meaning that I think this is where it's like it creates some helper functions, for example, to interact with Kafka or based on your annotation. It might even be something like validating messages on the run or whatever. Did you want to take this one, Lawrence?
Yes. So it's basically because I think like generating the async API specs from code is one part. For example, if you annotate one class as a channel, and then in this class you have a method and say this is the operation. This is one part. But if you actually want to annotate a message, so in class, you actually have to generate, for example, JSON schema. So some schema representation of your messages. This is what I mean, that you can actually auto-generate the schema from your code.
So basically this, right? So once you define a message and the type of that message, you should be able to generate JSON schema according to that, right?
Yes, right.
Technically also others, right? Yeah. Yep. Anything to this? Anything that's missing or something that doesn't make any sense? Or that shouldn't be there? Makes sense to me too. Schema registries. You can store full async API documents or partial documents in a schema store or a schema registry, probably. Either privately, publicly, that each tool will be able to use. So that means that if you integrate our parsers in your tools, like in other tools, they should be able to use schema registries. Like it's almost like a dependency going through it all. So that means that it can be used as part of all parsers and therefore all subsequent tools. Provide an API to store and retrieve documents, so it can be used as part of a larger integration if you want. Could also be that you want to use it as part of a platform. Could, for example, be what's it called? I can't remember. Yeah, part of the platform. Should be able to handle multiple versions of schemas as well. In an intuitive way. I actually want to add another. I just remember something. So it's basically this sentence.
With partial, you basically mean components, right?
As part of what, sir?
With partial, if you say partial, you mean everything that can actually be a component.
Yeah.
Okay.
That's a good one. Yeah. Anything to add? All right. Frameworks. It should be easy to use async API in your existing implementation on existing use of a framework and development workflow. So as a developer, you can reap all the benefits from or with async API instantly without having to change your implementation. So that means that we enable beyond just documentation. We make it easier to handle message payload based on the async API documents, making it easier to handle headers, topics. Yeah, don't have a lot in this one though, but it's kind of related to code generators as well, right?
Yeah, I would also say maybe we can also discuss it later, but maybe we can actually remove this as a tool and integrate the points that we have into code generators and code first, because it's basically an important part in both of those tools.
Actually, I will propose that we do that. I think that makes sense. Yeah. What do you think, Sui?
Yeah.
So what if we add a feature point to the code generator? I integrate it into so we add this one here. We remove this. And we have this one here under code first tools. So now we can basically remove it, right? I think.
Yeah, I think so too.
Any objections to it?
No.
No. Let's do that then. All right. Code generator. Let's take that last one then. It should be easy to save time, help catch bugs, or improve the code and the development process by using async API to generate code. Wow, what? By using the async API document to generate code. I'm just gonna do that. So that means that you can generate type models for the message payload a type model for headers, type model for kind of a topic message matrix. So you can match topics or addresses with specific message type. Helper function for interacting with defined channels through a provided client. So that means, for example, that we wrap a Kafka client library in, so you don't have to remember the channel addresses, you don't have to remember parameters, you don't have to remember headers, all of these things, because we provide you with a single function or one or more. Can generate full libraries that external users can use to interact with that specific application or system, which basically just is a full client library, like an SDK. It, of course, follows the best practices of the language and the framework. It is customizable. So if the user want to generate something on their own, they can do that, extend it. And it, of course, can be integrated into any existing framework or development workflow. Anything to add?
Nope.
So, all right.
No.
All right. So now we have this. Now what?
Maybe pick one and choose what you want to focus.
So you're suggesting that we pick one of the tools and focus on that first?
Yeah.
Mm-hmm.
We create a roadmap for like the multiple things I want to achieve.
Sorry, what?
So we create a roadmap for the for different tools I want to achieve.
I have a feeling that there are too many features and too many requirements and too many tools for us to even have create a roadmap for all of it at the same time. And I don't think that we can, and I don't even think it's fair that we select, for example, one of the tools and bring it to the end, like implementing all of the features, all of the things. I don't think that's possible either. It is over time, but I don't think we should focus all our energy on just one tool in the beginning. I think we have to do a little bit. Maybe we start with JSON schema files. Okay, actually, I want to suggest that we skip these two for now. We don't even consider them that much. We have them in mind, but we leave those two to kind of on a shelf for now. And then we focus on code first tools, parser, and JSON schema files. Because these two down here are, I think, without a code first tool, without a parser, and without very good JSON schema files, all of these down here doesn't matter. Or at least doesn't matter that much.
I agree with the code generators. I think those are really just nice to have. But I kind of feel like the schema registry is pretty important for for at least corporate adaptation. Because for example, there is a big problem, for example, if you have a AWS Lambda and you want to document it and you want some service to actually use this document, where do you get it from? Like the only option is actually to read it from GitHub, from the repository, right? But there you actually only have the one version. So it's I think it's pretty important to couple the schema registry and the JSON schema. I think they are pretty connected.
I can definitely also see the benefits of having a schema registry. And maybe included. I disagree with merging it with JSON schema because one is consumer based, like the schema registry is for users of Async API, for them to store their Async API documents so they are easily like shareable. Where the JSON schema files is basically like it's for our tools to validate and ensure that provided Async API documents are correct, right?
Yes. I'm just saying that maybe it makes sense to already have a look at the schema registry and maybe just start with a really simple version of it. Before we say, okay, the parser is done, the JSON schema is done, because like those are already pretty big lists, right? Before we actually are finished with the parser. I'm not sure how many years this will take to have it in every language, every feature.
Yeah, so that's also why I'm saying that I think we should probably prioritize each of the features. So we figure out a way. It can even be as simple as going through the feature list of like those 3 or 4 tools. So we have a must-have. It's almost like not a proof of concept, but almost like with these features, we are in a good, like, now we laid the foundation basically. These next features are something that like are really nice to have, but are less important. Like it's not something that we right now need to focus on, which also means that we can, for example, prioritize the must-haves for all of the tools, or for at least those 4. So we reach like that bottom layer that is probably achievable for us, even just this year or in the beginning of next year. So we have this huge scope right now. Now we find the most important core of the tools and work on those. And then we expand. That would be my suggestion.
We can also start with only one language, especially for parser, and code first to establish like what we want in all the languages.
I would highly recommend that as well, yeah. Maybe even if we, like, for example, that each of us has a very specific language in mind, and that's our, like, it is, that it's our focus area. Because that means that if it's just the 3 of us, for example, we can have 3 or 4 languages in focus.
Yeah,
sorry, go.
Yeah, I mean, for example, I think for the parser, I'm guessing the JavaScript or TypeScript library is probably in the best state right now. For code first, I'm not actually sure, but I think Kotlin is maybe not even that bad. And then maybe we can, for the parser, only focus on one language and for the code first on another language, where we actually see like the state of the libraries are actually the best,
Yeah.
and we can go from there.
Yeah, I think that's something that we need to do. I would probably suggest that we do the priority first, because then we have each of those features, because then we can compare it with the tools and see which one is missing these features or not, like something to compare with. By the way, just to get back to the registry, I'm sending you it was something on Slack. So there is some other already existing schema registries from Red Hat that is, I think it's open source actually. I haven't looked into it, which means that we might be able to collaborate with them as much as possible. So we don't have to build something from the ground up, especially if it's already open source. And it might enable us to quickly get started with integrating it into parsers, for example. Yeah, it's open source and it's Java. Perfect. So yeah, just wanted to mention that one. All right, so I guess the most important one right now is what's next, right? What's the next step now that we have this list? Any concrete suggestions how we move on from here, or what we can do as the next step?
I think what you said sounds good, to just agree on what is maybe the most important, and then see where all our libraries are at in regards to that list.
I agree. Sure.
Yes, sir.
All right.
You said.
So yeah, so let's so as always, since we can't make decisions on the call, we have the list now that we agree on. And then we make sure after the meeting to ping everyone in the working group so they have time to look at the proposal of the vision and come with changes before we finalize it next meeting. That's like from that point onwards, this is our guiding light, right? And what if we, as a home assignment until next meeting, we try and go through those 4 tools and prioritize them on our own? Just a simple, like, I would suggest that we just do like a must have, nice to have, should have. Maybe just those 3 simple priorities. And then next meeting we can finalize or discuss those priorities and see if we can figure something out. Does that make sense?
Makes sense. Maybe we can also add if any of us works on the library for those tools already, also like add what features are supported. Then we can already talk about this next time.
Yeah, we can do that. Maybe add it as an optional, So if people don't have time until this next meeting, if they just do the priority list, that's perfectly fine. But otherwise, we can always discuss it next time, right?
Yep.
Nice. Fast and effective meeting, eh?
Yeah.
Do we have
think-
anything else we want to discuss now? Anything you want to bring up?
No, nothing from my side.
I don't have anything either. All right. Quick meeting. All right, thanks, folks. I'm gonna make an update like I always do with actionable items and what's next. And then ping everyone in the working group, and then I'll see you next time.
Sounds
Take care.
You too. Bye.